Welcome to part 3 of this tutorial, where we try to model this area in combat mission Cold War. Last time we used CMAutoEditor to get a digital elevation model into combat mission, and this time we are going to populate this bare terrain with everything that we need for a map, like trees and roads and houses and all that. And we're going to use OpenStreetMap data to do this. Okay, for the really impatient ones among you, remember we had this map in JOSM, so the application with which we work on OpenStreetMap data, and we had just saved it as aga.geojson. And with that, we can just go ahead and click OSM to CM, or OpenStreetMap converter to combat mission. And we use as input file our aga GeoJSON, and we choose whatever output file we like aga OSM, for example. We can just keep the default OSM config.json. And when doing the elevations, we had produced this grid file, you may remember. We are just taking this instead of entering a bounding box by hand. So just browse, and we had it under elevations. Use this one, _grid, and not the other ones. And start OSM to CM converter. And wait a little while the converter is processing the data. And once that is done, we just open up CMAutoEditor. And read in aga OSM. Make sure we have the right new map. No, in that case, actually the old map. We want to have it on top of our elevation model. And we leave it just as it is, like this. And because this is already the second stage of our map, we check this box. So take the start size from file, only for continuing a map, which is what we do. Start CMAutoEditor, we see the countdown, we go back. And we watch all the hard done work we have made before vanish, but don't worry, it will come back. And we see our landscape unfold. Now this will take some time, and that's basically it. And with that I could conclude this part of the tutorial. Bye bye, see you in part 4. But that wouldn't be very educational now, would it? And so if you are interested in how this works and how to customize it more to better suit your needs, um, bear with me and we'll dig deeper and take a closer look. Okay, now I hope some of you stayed and not everyone switched off and said, that's it, I'm happy with that. So in order to dig deeper and better understand what we are doing here, I'm going to make a new map from scratch. And incidentally, this is also the way you can use CMAutoEditor to just make your own map if you are not interested to use something reality-based from OpenStreetMap, or to make your own World War II map if you happen to have some good topographic map or something that you can put into the background. Okay, let's make a new map, and that's quite easy. We just make a new layer and we remove the old layer, and let's zoom in a bit. So we just want to have a small map, so we don't have to always wait that long. Now, first things first. In OpenStreetMap, you have 4 basic types of, shall we say, objects. So the easiest one, the simplest one, is just a point. So you usually use this to represent just a single tree or something like that. The next one is a line string, which is basically just what it says. So a string of line segments. Then you have polygons, and you have multi-polygons, which is a combination of several polygons, where usually one polygon is the outer one, and then you have one or more inner polygons, which are used to represent holes in the polygon, for example. So for like a forest with a clearing in it or something like that. Okay, so we start by adding a river to our little example map, and we simply do this by adding a polygon. Now let's see that the river isn't too wide, like maybe so. And we add the most beautiful river you can imagine. Like so. Now, uh, for now, this is just a polygon, and in OpenStreetMap, you tell this thing that it's a river by giving it a tag. And you can either do that by hand or you can use a preset. Let's use a preset. And because a real river has some additional requirements, we just make it water and water. Yeah, so apply preset. And that's it. It's already painted blue. Symbolize this is a body of water. Okay, let's quickly save this example map. Why shouldn't we call it example map? GeoJSON. Right. Now, this is the OpenStreetMap side of things, but how do we translate this into Combat Mission? And this is where this default OSM config.json comes in that you may have seen already, and that we had chosen last time to process when using OSM to CM. Okay, now we'll take a quick look at this. Now it's a really large file, and I won't go into details here. There's a lot going on here, and instead of confusing you, we are going to make our own small example config.json. I took the liberty to already prepare the first entry instead of going through the pain and letting you watch me type live and in front of the camera. So what do we have here? Now, first of all, this format is, as the name says, JSON format. If you are interested in how it works exactly, please look it up in the internet. It's well documented and it's commonly used. So you will find a lot of resources on that. Now our first entry here, it starts with a name, and the name is river, but this doesn't have a real semantic meaning or something. So it's just a name. You could have named it ABCDEF. As long as it's unique, it doesn't really matter here. So you can't put another river name somewhere. You have to use something else then. And we have a section here called tags, CM types, process, and priority. Now this tags is the thing that hooks into OpenStreetMap basically. Remember, now we have natural water here, and this is well, let's choose this, and this is what we have here as key value pair. So natural water to identify this polygon as a river. So what basically happens is our converter goes over every OpenStreetMap object and then looks into the config file and then applies every entry that has this key value pair or tag combination. So this is how we trigger this basically. Now the next one is CM types, and this is basically where the translation happens. So it tells the converter, okay, we have an object in OpenStreetMap and we are applying menu ground 2 and then category 1 water to it. Quick look into combat mission, ground 2 water, that's this one here. So the entries are usually named, the entries for menu are usually named like the menu names here, just without the hashtag usually. And then cat1 is always this bunch of symbols here, and we can have something like cat2 which applies to things down here. The tags section here, this refers to the next entry, process. Process is, or under process you can find what then the converter is supposed to do with this entry. So here we have the entry type from tag, and this is a bit silly to use here because it's a bit overkill. Now you have one tag here, but you can have objects in OpenStreetMap that have several tags. And say you had several things that have natural water here, but then have other distinguishing tags like, or I don't know, something like that says, okay, this is a pond or this is a lake or something like that. And then you could use type from tag to put the tags here that should get water, or the tags in the next entry that should be converted to swamp and all that. It's just to give you an example here what this thing does. So here it's really just telling the converter, okay, you have an object that's natural water, so paint it with water tiles. By the way, don't worry that I use this super fancy editor. It's for this purpose just a good thing to have because it does better code highlighting, but you can just use Notepad or whatever you like, works the same. Um, okay, I'll just show you once how to run the OSM converter and CMAutoEditor with this, and skip this for the next increments of our example map, because that would get a little boring and would disturb the flow here. So let's just once head over OSM to CM. Okay, as input file, this time we use example map, and we give it another very creative name like example map.csv. And instead of our default OSM config, we use our own example config. And instead of using a pre-made grid file, this time we just say take bounding box from OSM file. In that case, the converter and afterwards CMAutoEditor will just use the actual outlines or the actual limits of the map to derive a bounding box from that. That's something you wouldn't usually want to do because usually your map is larger than what you want to extract from it, but for this purpose it fits perfectly. Okay, hit start OSM to CM converter. Now this should be very quick because there isn't much going on, right? And start CM auto editor. Right. Let's choose example map. Now this time we won't take start size from file, so we start with the usual 320 by 320 empty map. Yeah, and we hit start and watch the countdown, add over, and see what happens. Okay, and there is our little river. Right. Okay, so we are done here. Let's take a quick look back. Okay, roughly 500 meters. Its minimum size of 208 meters. Yeah, looks okay. Quick look into 3D preview. Everything as it should. Right. Okay, going back, there's one thing I didn't talk about, and that's this priority entry. And let me just say, we come to that later. Now we had our little river here, and so a polygon filled with just one fixed tile, and that's okay for having a river. But now let's say we want to have a forest, and it would just be a little boring to have just one type of tree there. Um, so for that, let's add a little forest. Um, let's say north of this river here. Yeah, why not have it like this? Yeah. Okay, and we we'll use a preset. So it's geography, nature, forest, and we'll just leave this as it is. And now you can see this is painted green, so it's a forest. Okay, back to our config. And as you can see, I've already added the entry here for forest. And now we have tags land use forest. Let's take a look. Same here, land use forest. And by the way, we could have used any key value pair we liked. We just do the standard OSM notations here. But we could instead use a key Bob and value add-on as long as we do the same here. That works just as well as using standard OSM notation. Okay, so tags, land use forest, and now CM types. So there are 6 different. We have menu foliage this time, cat1, tree A and tree B, and now we have in addition a cat2 entry. And now if we look at the commit mission editor, foliage and trees, now those don't really have names, so I've called them because it's about tree density, density 1, 2, 3, and 4. And so we have for our forest density 1, 2, and 3 for 2 different tree types. And now we have under process type random individual instead of type from tag. So what does that mean? It means random individual says, okay, we have this area, this polygon that we chose, and for each combat mission square that is covered by this area, the algorithm will take a look and throw a dice. And now, not all the entries here are weighted equally, so we have in addition this weight entry here. It's optional, but usually tabs to have. So that means with this dice roll, our tree A density 2 is twice as likely as density 1 or 3. So sorry to bore everyone who already knows this. Weights work like this. You sum up all the weights. So in this case, that's 4, 8. And now the probability for the dice or the die roll, whatever, choosing this entry is then weight over the sum of weights. So in this case, it would be 1 over 8, which is like 12.5% or something. And so for this, it would then be 1/4, so 25%. Okay. Now this may sound a little dry, and now remember I told you I'll skip the conversion and CMAutoEditor, and we'll directly take a look how this now works out in Combat Mission. And our result in the Combat Mission editor looks like this. See, we have our river still, and now there's a forest with different trees and different numbers of trees. Let's zoom in. So 1, 3, and 2. And let's just look at this in 3D. Yeah. Maybe I should have chosen autumn instead. So the trees are a little easier to separate. Okay, but they have different heights, so that works. Now there's a third way in which to paint polygons, and for this, let's say we want to have a little bit of farmland on our map, so different fields. So like Yeah, they don't have to look that nice. 1, 2, 3, and another really realistic one like this. And we'll mark all of them as farmland. And now instead of using a preset, um, just to show you, we use add instead, and we do land use farmland. Right. Now this is also green, but yeah, it's not even a different green, I think, but it's fields instead of forest now. And the new entry in our config file looks like this. So we have farmland here, land use farmland, and we have 3 different crop types. And I should remove that comma. And this time we have under process type random area instead of type random individual. Now, what does that mean? Okay, last time we had for the forest we had the algorithm randomly choosing one of those tiles um, for each square in that is covered by this polygon. That would be a little stupid for farmland because that would mean that we would have fields where every combat mission square has a different type of crop. Now instead we want to just have a crop randomly chosen for each distinct um, field, or in this case for each distinct polygon. And this is where process type random area comes in. And I'll just quickly show you how this works out in combat mission. But before I do that, I neglected to mention what this active entry means, and it's really nothing big. It's just a convenience thing. So if you have a large config file, sometimes you want to switch things on and off without deleting them, and you could just set this here to false instead of just deleting it. But I'll delete the entry not to confuse you. Right, in that case you have to remove the comma because JSON works that way. Right, and now let's head over to combat mission. See, we now have 4 different fields, and actually there's 2 with crop 1, 1 with crop 2, and 1 with crop 3, very obligingly for this demonstration, but because it's random, it would have been perfectly possible to just have each of the 4 fields painted with just crop 1. Happens every now and then when I do this. But yeah, this worked out the way it should. And now you see, instead of having a random choice for every square here, like with the forest, we have now random choices for the whole area that we painted here. Okay, now we had several things we can do with polygons, and there's one more coming up later. But for now, let's go to line strings. And the most common thing that comes to mind for line strings is painting roads. So I think it would be nice to have a road that goes parallel to our river here. Let's say this is something like a primary road. Yeah, and we'll have an intersection here with a bit of road going south. And we'll have a little track that's going in this direction, and I'll be root and just paint it across those fields here. Okay, now how does that work? So primary, that means we just do highway primary, and say this could be something like a residential road. We want to have a little settlement here later on, so highway residential. Yeah. And this is just going to be a track, highway track. Okay, that's it on the OpenStreetMap side. And here's what it looks like. So we have our residential road just with paved surface and nothing else. We have our dirt road here. And we have this primary road here with the white lines. And see what I told you? Because I had to redo the map with the new update. Now the fields were chosen differently. Now we have 3 times the same crop and only one different crop. Well, that happens. It's just random. But anyway, so we still have different line string options here. And this time we will do a wall because, as I already said, we want to have a very small settlement here. And I think this settlement should be surrounded by a wall. But first of all, we will add a little more road here going into this future settlement. And maybe it should look like so. Maybe I'll remove the last points here and 1, 2, 3 side roads. And I will also add another little dirt road. I'll come to that later. Like so. Okay, now we wanted to have a little wall. And that is easy to do. And we'll have it just like so. Okay. Yeah. Now we have to put the correct text here. First, those additional roads. So this is another track, and we want this to be residential, a residential road, and this too. Highway residential, we still have it here. Yep, and this should be a wall. So walls are barrier wall. Okay. Yeah. Hopping back into Comet Mission, we can see what the effects of our deeds are. And you can clearly see our little rural wall here. One thing you can also see, and I don't want to withhold that from you, is one caveat that the wall drawing algorithm has right now. It does like to cut corners somehow. You can see that here and compare it to here. This should be a roughly 90 degrees angle, and this here and that here clearly isn't. Oh well. Okay, what's next? There definitely needs to be a stream in our map. Like, I think could go this way and then here into our river. We can use the preset for this stream. And voila, a stream. And because that won't be super new right now, we will combine it with another new thing. I already told you there's a fourth OpenStreetMap object type, and that's multi-polygons. And so I will add a forest here that has a clearing in the middle, and we'll do that with a multi-polygon. We start by doing the outer line of this forest, like so. Yeah, that's good enough. And we should have this hole in here, roughly like this. So then we select the outer line here, and we select these nodes here, go to tools, create multi-polygon, and then we do double click on this, and you see this here is already marked as outer, role outer, and then we select the inner line here and add it here to the bottom and add apply role inner. And then we will mark it as forest and use forest. And I'll do one thing in addition. I add leaf type needle leafed. Okay, and what that means I'll show you in a second. Right, that does it. Okay, then let's hop over to our config. First things first, here's our stream entry, waterway stream, and yeah, that shouldn't really surprise you anymore. It's just like fence tiles and road tiles, and now we have stream tiles, and we have menu roads and cat one stream. Yeah, just like we are used to. Now the somewhat new thing here is our needle-leafed forest. The reason is this. Imagine we have this generic mixed forest, but sometimes you want to have something special, yeah, like a forest that only consists of some trees and not all of them. Now we want to have a needle-leaf forest here, and we have this extra tag, and we put this here under required tags so that this needle-leaf thing only applies to forests which have this extra tag. And that only makes sense if in combination we go up to our generic forest, this one, and add exclude tags leaf type needle leaf, so that this other thing here doesn't apply to our needle-leaf forest. Okay, and I've added one more thing. I've added this dummy entry here. And this is because I, in addition, want to have some empty patches here and there where there's no tree at all within my forest area. And I can do that by just giving CMAutoEditor something it doesn't recognize, like a key value pair with dummy and a boolean true, or I could just call this Bob colon Ellen or whatever, and I give it some weight, and so we should have like, if this adds up to 5, like 20% patches where there's no tree at all. And otherwise we will just have our tree type H here with the different densities compared to our generic forest that had tree types A and B. In Comet Mission, the result looks like this, just as it should be. Here's our stream, and here is the forest with this hole in the middle and some random patches with no trees at all, and them just as it should be. And we go to 3D just to see if that tree thing worked out. Yeah. So we have here this type of tree, and only this one with different densities though, compared to the other forest. Oh, this time we have winter, and I usually showed you summer, but yeah, never mind. Different trees, obviously. There's our stream here in 3D again, and it goes through here. Yeah. And ends up in the river here. All as it should be. One major ingredient for our map is still missing, and that's of course buildings. And they are easy to add because it's just polygons, and we can just draw rectangles here. Let's add a few here into this wall enclosed area. Let's not make them too big. I guess like so would be okay. Yeah. They don't have to be perfect rectangles. It's more like the algorithm tries its best to roughly match the size and outline and orientation, but not that much more than that. That is, it actually matches the squares that are covered by these rectangles or whatever form the buildings have, and tries to build something out of that that has roughly the right size. Let's have one more here. And of course, we should have a church in here. Like so, yeah. And then one more thing, we have we should have some larger building complex, whatever. Um, yeah, I mean, maybe it's a warehouse of some company, or it's the sports clubhouse, or whatever. It doesn't matter. Just a bit larger than the average building here. Yeah. And of course, we have to tell JOSM that they are buildings, and that's really simple to do. We take the simplest form of building, and it's building equals yes. Very creative, isn't it? And we make this a church. And by the way, you can up this here and see what preset key value pairs, or in this case values for the key building there are, and we just choose church here. And in our config file, this looks like so. We have houses here and churches. We have those separate. Building, and we allow independent buildings and modular buildings, both for building. Yes, this is basically like you already encountered with type from tag, for example. But the process here is type from residential building outline. It's a somewhat different algorithm, and we have to use separate process types for residential buildings and churches. That's not super beautiful right now, but it's not just about a different set of tiles, but those buildings have different sizes and all that, and so for now it has to be a separate process. Maybe that changes in the future, but it's okay like it is for now, I think. Okay, and in Combat Mission, the result looks like this. We have our different buildings here, and it's 1, 2, 3, 4, 5, 6, and that should be the church. Quick check, 1, 2, 3, 4, 5, 6, and this one, right? And then we have this big thing here, and that's why I wanted to have modular buildings in the config too, because if you have that, in cases where the building algorithm finds a polygon that is significantly larger than any single building in Combat Mission, it will instead try to fill up that polygon with uh, as many buildings, not as many buildings as possible, but to fill up as much space as possible with as few buildings as possible. That's the correct way, yes. And there's one more thing you should note. We have a different number of stories, levels in this for these buildings. And while it is possible in principle to use OpenStreetMap for that, this is a feature that's rarely set, and so I didn't bother to put it in as of yet. So the numbers here, 1, 2, 3, is just randomly chosen, with 2 being the most probable one, and 1 and 3 less often. This obviously fits a rural setting much better than some urban settings, so just so you know, it won't fit that well if you want to do something. I plan to change that in the future, but obviously it isn't there yet. Quick check in 3D. And here's our church, here are the buildings, and this is our larger modular building. Now, I've already prepared this, so usually you will have your random set of roofs here as usual, but I made this look a bit more like something more modern. But then, of course, you would have to have some uniform painting of the walls and all that. Um, well, that's something you have to do by hand, of course. Um, yeah, so while we are here, what's still missing on our map? Uh, the, the major ingredients are all there, I'd say, but especially this settlement, it does look a bit sterile, I think. So we should add some beautification here that makes it look more natural. Also, I think this stream, yeah, maybe we should have a bit of muddy ground here. Um, yeah, and of course, those forests in general could do with a little forest ground, I think. So we'll add all of that and maybe some flavor objects like, say we should have a bus stop somewhere here or a bench here and there, and we can add that too. We'll get to that in a second or three. If you listen closely, there is one OpenStreetMap object type that we didn't look at so far, and that's points or point-like objects. And this is the way we do single trees and flavor objects and stuff like that. Um, so in order to add some single trees, we just add a point, like so, and use, for example, a preset nature tree. And let's just randomly Control C, Control V, just as usual, and we add some random trees here and there. Maybe we could make this here something like an avenue, and let's have one here and here, maybe one here at the wall. Here, small cluster. And in the same way, we can do bushes, for example. So we add presets, geography, nature, shrub, and earth. Yeah, just put some of them here and there randomly, because why not? And we'll have a few here, maybe something here to separate the fields. Yeah, and that's it. Let's not overdo it. So I said we could have a bench. Where would be a good place for a bench? Maybe here next to the church somewhere. Maybe here. And that is something that's, let's remember. I think it was amenity bench. Yeah, okay. And we have a little bench symbol here. And then we wanted to have a bus stop. And that's, for example, I think it was highway bus stop. Yes. Yeah, and we put that here. Okay, that's good. Hmm. Yeah, why not? I mean, it's not really terribly new. We know other line segment like objects, but let's have a hedge or two. Uh, maybe, mm, 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 like going this way. We mark that similar to walls as barrier hedge. Yeah, and we add some more hedge things here. Okay, that's good enough. Yeah, that's, I think, enough on the map side of things. So, and how does our little project beautification look like in the config file? Okay, so first of all, we had single trees, and it's a natural tree, like the tag, of course, in JOSM. And this time, we just have all the trees with all the densities here to choose from, because I was lazy and copied it from default OSM config. And now process here is single object random, which just says, okay, take a single object and choose randomly from one of those types. Now, single object means single object in OpenStreetMap. Of course, if you have density 3 here, this can be 3 trees where we placed one tree in OSM. This is just to give it a bit more variety here. It looks nicer from experience. Okay, same thing with bushes here, similar structure, different weights. By the way, you see weights as int here and weights as floating points. Um, the weights are always treated as floating points, so you are not restricted to have whole numbers here. You can have some comma values. Okay, there's a hedgerow here. It's fence tiles, but this time we have low bocage here. So nothing super fancy. There's our bus stop. Now it's flavor objects. And there's one thing to note here. So flavor objects shelter, so far so simple. That's as it is called in combat mission. And now object 1, 2, 3, this refers to, if we go back to the editor, this refers to those numbers down here. So for example, that would be object 1, 2, 3, and 4 of gravestone, or yeah, 1 to 5 of pallet or whatever. Okay, so that's bus stops. And what do we have next? Yeah, there's a bench, and there are a number of bench flavor objects, and it can just randomly choose one of those. So far, so simple. Now a little more complicated, stream ground. So we want to have some muddy ground where the tree goes through. And for that, we have type from linear, and um, that's because so it's not entirely clear right from the beginning where this linear object will be, because as I mentioned, there's some kind of pathfinding algorithm that determines where such a line string goes. And so we have to use that and use this modifier here and say linear name stream. So it looks if there are tiles with, or no, I should say squares with a stream in them, or with something with name stream. So this refers to this name here, or better put to, where's our stream? This name here, and then applies ground to mud to it. Okay, and last but not least, forest ground. So that's another, shall we say, dual use thing. So we already use a forest polygon to actually paint trees in them, but it's not that you have a that you have to have only one combat mission object matching one OpenStreetMap object. Instead, for each OpenStreetMap object, as I told you in the beginning, I think, the program will take a look which tags trigger this entry here in the config. And so if it's triggered several times, like once with the forest, with the trees itself, and once with the forest ground, that works too. And this here it says, okay, so we have this tree, no, we have this land use forest polygon. Add ground to light forest and heavy forest to it, and we want to have one heavy forest for every 5 light forest ground squares here. And again, as we had it before, not with the single object, it's we have, but with randomly chosen squares for an area, we do type random individual here. Okay, this was really a lot for one iteration, and so let's take a closer look at how it looks in Comet Mission. Okay, I think this one time it's appropriate that we just watch the process unfold with CMAutoEditor itself. And we go over here and just watch how it actually unfolds. So I, for one, like to watch this because it's, well, I don't know, it's kind of relaxing. It is. And as you can already see, there's our hedge, there's our rural wall, there are the mud tiles for our stream, and there's forest ground. Different types of forest ground and mud in between. There is, yeah, those are the bushes that we planted in between the fields. And as you can see, you can have 2 or 3 bushes in Comet Mission for one object in OpenStreetMap, because that's what the config file said. Yeah, those are on the left side, those are the trees we set to line our primary road here. And there's also our hedge that separates the 2 fields. Okay, and we are done. Let's take a look. Yeah, looks like everything is as it should be, but we'll take a closer look. Again, I didn't set it to summer, but it's still, so it's still, oh, it's March, so it's technically still just winter. But yeah, here is our hedge row separating the fields, the forest, the mud around the stream, forest with forest ground in between. Same here. Uh, Trees lining our primary road. So there should be a bus stop here. Ah, there is. Nice. And there should be this bench. Yeah, so it's a flavor object, and CMAutoEditor, as it can't do anything in 3D, will just put it into the right square. You will have to do the exact placing yourself. We do that like, yeah, why not like this? Nice view towards the church. Yeah, we have the hedgerow here and some bushes and trees here. Of course, since we rebuilt the map, uh, our roofs are reset, and as I said, the number of stories here or levels are randomly chosen. And maybe you noticed last time I think it were 2, now it's 3. Um, but it's identical for all of them in this larger piece here, and the rest is randomly distributed. So I think that was 2 last time. Anyway, yeah, some bushes here. Yeah, I think this is beginning to look like a map that is actually ready to use. Of course, all the excellent scenario and map creators out there aren't unemployed just yet. There's still a lot of things you can do by hand, and still a lot of things you have to do by hand that haven't shown here. For example, CMAutoEditor won't do bridges. That just doesn't make sense. They are so hard to place, and since they can only go 0, 90, and 45 degrees, doesn't make sense to do that automatically. And there are other things you better do by hand. Um, but yeah, for a map that we just painted with some lines in OpenStreetMap, this does look like a well, reasonably good map in Combat Mission, I think. Now, there's one more thing I didn't tell you so far, and you may already wonder what happens if two objects, say areas or whatever, happen to be in the same place. Who wins? And this is where this priority entry comes in. And the rule for all the numbers greater 0 is actually fairly easy. So it's always the smaller number, as long as it's greater than 0, wins against the higher number. So if, say, we have two polygons and say two fields, or now let's say there's a forest and a field that somehow covers the same square in Combat Mission, and the forest has priority number 1 and the field priority number 2, the forest will win out. Okay. Um, for linear objects, so like roads, fences, and all that, there's an additional rule, so to speak, here. Um, uh, if the priority is larger than some other linear object that's there, the road, for example, or fence will try to uh, search a path around the lower priority number object. So say you have a road already and you paint a fence there. The fence, the algorithm will try to find a path for the fence that moves a little around a road if it's in the way. And if the diversion is too large, then it will the fence will just get split. Um, so as I said, this all applies to if the priority number is greater than 0. There are two special numbers, or let's say there's one special number and everything that's 0 and everything that's below 0 is treated again in a different way. Things with 0 just get always painted or well end up uh, in the file that is going to be processed by CMAutoEditor no matter what. So if say we have a road there and then there's something like a field, so the road has priority. Oh, let's just take a look. Roads, we had them here somewhere with, yeah, priority 2, and say we have a field, farmland here, priority 0. It means the farmland will be painted on the combat mission map even if there's a road in the same square. From the CMAutoEditor side, if it doesn't work in combat mission, that's a different issue, and then whatever gets painted last will win, of course. Um, but from the CMAutoEditor side, it works out like that, and you can have roads and fields on the same tile. That's or same square. That's as it should be. Now, okay, buildings are slightly special in that they also they have I put them to a priority number larger than 0, greater than 0, but yeah, so the building placement works in a way that the algorithm takes a look at how much place there actually is, and if there are, say, roads with a lower priority number somewhere overlapping with the squares the building should occupy, then the building size will be reduced by the occupied squares. Um, yeah, in case the building has a larger priority number, of course. Um, Now I said priority values smaller than 0 are treated differently again, and that is true for streams, for example. Um, uh, Such that although they are linear objects, they won't care about what other linear objects they are. They won't try to maneuver around the roads, and that is why, let's take a look. That is why I drew this little way here just to demonstrate this. The stream just went here and it didn't actually get split. It was just painted over by this here, and that's the other feature. It will, shall we say, lose against every other feature that has a priority value that is greater than 0. We do want that for streams because imagine we have a more complex elevation terrain. So then if we don't do this and the stream is diverted by some road, then we quickly have situations where we have streams flowing uphill and all that, and we don't want to have that. Now, in addition, we have the forest here at -1, and that is somewhat related to the stream. So let's go back to combat mission here. You can see that trees were removed where the road went through. That wouldn't have happened if I had put the forest at priority 0, but we could have had the same result if I had put the priority value greater than that for the road. So let's say I would have put it at, say, 5 or whatever. The trees would have been removed too. But in that case, remember the stream here would have been deleted too, and I didn't want that, so I put the forest at -1 so that it gets so that the trees get removed where there's a road, but it doesn't supersede the stream. And we have the forest ground at 0, and 0 doesn't do anything harmful, so to speak, to -1 things like the forest and the stream. Okay, that's a bit complicated, and I think you have to think about it a little more, and I guess I have to talk about it in another tutorial again, because it's really not that simple. But yeah, it's also not that complicated, and usually you don't have to do much about it. If you, for example, you just take the default config, well, go with it, it should work, and otherwise play around with it a bit. Okay, so I think we are done with this example map here. That's all I wanted to show you. Now, I still owe you one more thing. Um, Remember right at the beginning, um, I started generating the Aga village map. So our map we started out with wanting to create, and for which we had the elevations already done. This is here. And I zoom out a bit. I already showed you that here quickly. And if we look at it in 3D, yeah, that looks nice. This is our hill here. No golf area, by the way. And yeah, so that should be roughly the view we had in Good Earth. Okay, now, as I said right at the beginning of part 1, there should be a part 4 where we basically do a bit of the beautification that we did for our example map. Yeah, so anyway, to cut this short a bit, I think all the basic ingredients are here. We will do beautification, and of course one more thing that's missing, and that's why we had this aerial imagery. We have to transform this back to 1980, or well, 1990 in that case, and remove some of the buildings. I don't think it was that many, if at all, but we'll take a look. I'd say this closes part 3 of this tutorial, and I hope I see you, or you see me, in part 4 of our tutorial series here, where we are going to finish our little CMCW map Yeah, and with that, see you next time.